Hello, so we'll continue with the last two types of reactions, which are the substitution reactions and the addition reactions. So when you talk about substitution reactions, they can be of two types. You can have the concerted ones and then the ones which are non-concerted. So concerted means one step and then non-concerted means two steps, right, or slow. So suppose you had a molecule that looked like this, right? If you had a molecule that looked like this, one thing you'll be able to see is you have your substrate, which is an alkyl halide. So you have the halide group attached there at that position. So first thing that could happen is that you have your nucleophile. This time it's not a base, but it is a nucleophile. So your nucleophile has this desire to attack a carbocation. Reason, because it has it's carrying a negative charge with it, or it has this ability to want to donate a pair of electrons to a non-hydrogen atom. So how is it going to do this? So there are two ways that this can be done. So it can be done either in a concerted fashion or in a non-concerted fashion. So suppose we had a molecule that looked like this. So the first way this reaction could proceed would be in a concerted fashion. So if it was to happen in a concerted fashion, one thing you'll be able to see is that your nucleophile, in this case, will attack the carbon, right? Why is it attacking the carbon? The reason is because the carbon and the halogen have a very big difference in electronegativities, making the halogen more negatively charged. It has a slight negative charge, and then the carbon will have a slight positive charge. So in order to neutralize this positive charge, the nucleophile will donate a pair of electrons to the carbon, thereby forming a bond. When this happens, the carbon will be attached to 5 things, and you know carbon does not like to make 5 bonds. 5 bonds is just too much for carbon, and so one of the constituents or one of the attachments must detach. And who better to detach than the leaving group? So one thing you'll be able to see is that the halogen will leave, and then you have your product like that. The second way this mechanism could, this reaction could proceed would be if the leaving group leaves first. So when the leaving group leaves, which is the halogen, it creates a carbocation that stays back. So you need to take note that if rearrangement is possible, please rearrange, because carbocations like to sit on high degree carbons. So in this particular case, what happens next? The nucleophile will attack the carbocation, and as soon as it attacks the carbocation, one thing you'll be able to see is that you get your product like that. That's a typical example of how a substitution reaction occurs. The last type of reactions are the ones we call addition reactions. So addition reactions will be explained in more detail, but a basic understanding of addition reactions would look like this. So you would have a compound that looks like this. Usually it's got a higher degree of bonds. So you have a compound like this, and then you add something else, like let's say X and Y, and then you form something that looks like this. It's typically adding, right? The key thing you need to know is that an addition reaction could be thought about as the opposite of an elimination reaction, because addition reactions will move from higher degree of bonds to less degree of bonds. So an addition reaction could move from having a triple bond to a double bond, or moving from a double bond to a single bond. So having covered that, that would be the last thing we'll talk about, and then in the other lessons we'll dive deep into these reactions.